page 2 of our discovery worksheet packet looks at what happens when we have a power to a power. Right? We have stacked powers here. So what really happens if I have my outside exponent here is to the third power, that means whatever is inside is repeated. Remember, exponents is repeated multiplication that many times. So this 3 squared has to be repeated 3 times. So, and I know 3 squared, if I expand that, is just 3 times 3 because it's repeated multiplication. So 3 sets of 3 times 3 leaves me with 6 3s, which simplifies to 3 to the 6th. So if I expand 4 to the 3rd power all to the 4th power, that means I have to have 4 sets of 4 to the 3rd power, which gives me 12 4s. Okay, 3 sets of 2 to the 3rd power. 2 to the 3rd power is 3 2s, and I have 3 sets. That gives me 2 to the 9th power. 2 to the 4th power, all to the 2nd power, means I need to have 2 sets of 2 to the 4th power. 2 to the 4th power is 4 2s multiplied together. I have 2 sets of those. That means there are 8 2s, so I have to take it as 2 to the 8th power. Okay, 1 set of 8 to the 3rd, really, we won't really see it written here with a 1 on the outside because 1s are kind of just implied. It doesn't really change it. It's still just 8 to the 3rd power, right? But showing you that step should have helped you realize, if you didn't get it by then, what our rule is. We have a power to a power. You simply need to multiply those exponents. Okay, that's the pattern. If you look across, we're multiplying those exponents. So if I have some number x to the power of m, all to the power of n, I simply need to take that base and put it to the power of my exponents multiplied together. So then, does the rule work for 3 to the 2nd power, all to the power of 5? Yes, it would just become 3 to the 10th power. Realize if we're simplifying this, then we would actually have to do 3 to the 10th power, but this is good enough for the discovery worksheet. So that's page 2, power to a power. You were also supposed to do page 3, so if you didn't, make sure you do that before continuing with the video. So page 3 is looking at product to a power. So product means multiplication. So if I have 2 things being multiplied together inside parentheses, and I'm taking that whole quantity to a power, what happens? That's what we are discovering on page 3. So remember, the exponent is repeated multiplication, and it wants to repeat the multiplication of 3 times 4 twice. So 3 times 4 times 3 times 4. Because it's all multiplication across here, you can rearrange it to group your 3's and group your 4's together, which then lets you see that this can be rewritten as 3 to the 2nd power times 4 to the 2nd power. So if we kind of follow that trend all the way down our worksheet, we need 3 groups of 2 times 5. So, and then regrouping our like numbers together, that simplifies to be 2 to the 3rd power times 5 to the 3rd power. Okay, 6 times 3, 4 times. That makes 6 to the 4th power, 3 to the 4th power. 4 times 5, 2 times, 4 squared times 5 squared. So the pattern, hopefully you got it relatively soon, is simply we are basically distributing this exponent here. So that becomes x to the power of n, y to the power of n. So does it work for 1 times 13 to the 3rd power? Yes, it does. Just distribute that 3. Again, we would simplify this further in an actual problem where you were asked to simplify. But that's good enough for this worksheet.